Recently, I've been wanting to build a flywheel that can launch these little discs here. These are small Nerf discs, and they go into this flywheel here. They get compressed and then get shot out. This is a little brushed DC motor from Amazon, and this is a small piece of aluminum as well as a 3D printed mount. I wanted to do some physics calculations with this flywheel and these discs, but I wasn't sure how fast the flywheel was spinning. So rather than buying a tool that would take significantly less time and a lot less headache, I built a tool instead. This is a stroboscope. So how exactly does this work? It's time for a little stop motion animation about the stroboscope. So let's say we have a light source, like this one. And we also have a wheel, like this one. I'll draw a line on the wheel so it's easier to see it spin. If the light is flashed at the same rate or frequency as the wheel is spinning, then our brain will play a trick on us and will look like the wheel isn't moving. This is because the light is only on for a small portion of the wheel's rotation, and the wheel doesn't move much during this time. Also, since the light flashes at the same frequency, our brain will focus on the wheel when it is illuminated. In this example, the wheel is rotating at the same frequency as the light is turning on and off. So the wheel looks like this. If we flash the light twice as fast, like this, our brain will see a combination of this position and this position. Basically, it's the stroboscope's job to change how fast the light is pulsed. And, since we know the frequency, we also know how fast the wheel is spinning. Here's me finding the speed of things, like this ceiling fan. Using the stroboscope, I found out the fan was spinning at about 2.2 Hertz, which, converting that to RPM, is about 130 RPM, which makes sense for a ceiling fan. I then tried to find the speed of the flywheel, and it wasn't easy. It was hard to tell if the stroboscope was flashing at the right frequency or not. I came to the conclusion that the flywheel was rotating about 15.3 Hertz, or around 920 RPM. Thanks for watching. If you'd like a schematic and/or code for this project, leave a comment and I'll put a link in the description. I didn't create a schematic for this project, but if a few people want one, then I'll make one.